we'll get started. Okay, so that was test 3. I'll try to get them graded, and I'll do some grade calculations, and I'll send you guys an email before next week. Next week is the final exam, and so today we'll just we'll review a lot of stuff from chapter 7, 8, and 9. And I'm still in the process of writing the final exam for this class. So generally, final exams are cumulative and cover stuff from the entire quarter. That said, I don't know exactly all the topics that Dr. Gimsari covered from the first half of the class. So I have an idea, at least from seeing test number 2. So at least I know the stuff that was covered on test number 2 is fair to put on the final exam. And so probably the final exam will there will be parts taken from test 2, parts taken from this test that you guys just took, and maybe a few more topics from chapters 8 and 9 that didn't make a showing on the test. The final exam, I'm gonna write it so it's multiple choice. Okay, I know students don't like multiple choice, but that just helps with the grading process in terms of getting you your final grades as quickly as possible. So the final exam will be multiple choice. What I'm thinking is maybe I'll write like just a couple pages of notes or big picture things from the first half of the class that I'll email to you guys, and just say maybe anything on these 2 pages or so is also fair game in terms of conceptual questions. So, like for example, if I asked you, what's the point of a standard deviation? What would you guys tell me? Standard deviation is not the distance from the mean.
Variable, how variable the number is.
Okay, all right, there we go. So, can you elaborate a little bit more?
Is that how wide the spread is?
Okay, yeah. So the standard deviation, the point of having a standard deviation or finding the standard deviation is it gives you an idea of the spread, which tells you, and what does the spread tell you?
Variability of the data.
Okay, all right. Well, and what do you mean by variability of the data? Oh.
Consistency.
Okay, are the numbers similar to each other, or are they very different from each other? Okay, and a standard deviation can be found for only what kind of data? No. Numeric data, okay? You can't have a standard deviation for categorical data. You can only have standard deviation for numeric data. And the point of having one is to give you an idea of, are the numbers very similar to each other, or are they drastically different from one another, okay? So these are, so that went a little bit rough. But these are kind of the big picture concepts that, when you finish taking a statistics class, you should be able to tell your friends what a standard deviation is, right? Because standard deviation, like, you covered the formula and how to find it and all of this stuff, but if you have no idea what it is or why we even bother, then it's no good, right? So I'll probably send just like a, I don't know, brief thing of notes with some big picture concepts that I think are important in terms of saying you got a education in statistics, and then I'll pick out some other things. Yeah, Shauna.
Can we have 2 pages of notes?
Well, so I'll say 1 page front and back. Okay, 1 page front and back. Still, is that okay? So you got to just be a little bit more efficient, right? So today you had a 1-page front and back, and it was chapter 7, 8, 9, and then the final exam you'll have 1 page front and back, and you'll just want to be able to either fit more or just internalize some of the stuff that that maybe you know already. Yeah.
I'm gonna type it, so it's
Yeah, you can
smaller.
type it. Okay. That's fine. That's fine. Okay. So probably the final exam will be all multiple choice stuff from chapter 7, 7, 8, 9. A few things from test number 2, and then a few things covering kind of my, I don't know, big picture concepts related to statistics. Yeah. Yes.
So since we have 3 hours for the exam, can we expect it to be about 3 times longer than that test?
It will probably be maybe 2.5 times longer than this test. Okay. So. Yes. No.
No, I was just gonna, basically the same thing I was gonna ask. you a
Okay,
question,
so-
if you were-
Well, I'll time myself, and I'll give myself like 20 minutes. Okay. And, if I can do it in 20 minutes, then you guys can do it in 3 hours. Okay. But okay. Well, I don't know. I mean, but it
But how many more years experience do you have?
yeah, I got 9 times more experience, so
So
I
that should be
get
9
one.
times more
Yeah.
than
20 minutes times 9 is 3 hours. There you go.
Major league.
That's a question.
All right. Okay. Well then, let's review. Let's review. So, issues with stuff that was covered on the test. So the topics that we saw on today's test. Just make sure. The very first problem, that was on central limit theorem. For proportions, okay? And then the second problem was confidence intervals for one sample proportion. Third one was a hypothesis test for one sample mean. Fourth one was a confidence interval for one sample mean. And the last one was a hypothesis test for 2 sample proportions. Alright. Anybody have any issues or questions or problems with any of these? Yes.
When we were doing one of the hypothesis tests,
Uh-huh.
if you reject the null
Uh-huh.
and then you have evidence, how do you explain that in your?
Yeah, so whenever your p-value, so you go through the process and you find your p-value, if your p-value is less than alpha, you reject the null hypothesis, and you say, we have evidence that, okay, and whatever the alternative hypothesis says, whatever claim that says is true. So you say, we have evidence that, okay, the alternative, whatever the alternative hypothesis says, true, okay? So you might say we have evidence that there is a difference in proportions if it was hypothesis tests for two sample proportions, okay? We have evidence that, you know, there is a difference in proportions of people, you know, who prefer, you know, XYZ between group 1 and group 2.
And do we have to show it like that p-value is greater than or less than the alpha on the test? Or can we just compare it?
So yeah, I mean you can just compare it and say point, you know, 0.015 is smaller than 0.05 or something like that. That's fine. If you write 0.015 is less than 0.05 or something, okay. Okay. All right. So no questions? We're all gonna get 100% on this test right here? Yeah. Okay, Rosie.
Do you mind doing a hypothesis test with two samples?
Proportions?
Yes.
Sure. You can do that. Yeah.
Maybe even some that were on the test.
Yeah, sure. Why not? All right. So this one says market researchers. Okay. So let's say so this was just on. Wait. Who's Okay. So basically, if anybody says they were absent today and they want to take a test there, I'm going to just say no because I'm putting the answers here on the video here. Okay. All right. So question number 5 said market researchers want to know if people who play video games prefer the new PlayStation or new Xbox. All right. Does anybody here care? Okay. It's like a big deal in the nerd world. All right. They found and asked
Xbox One?
Xbox One. That's it's getting a lot of hate right now. All right. They found and asked 600 randomly selected people who currently own an Xbox 360 and 650 people who currently own a PlayStation 3. Group 1 are the current Xbox owners, and the sample has 600 current Xbox owners. Of them, 420 say they are planning on buying the new PlayStation 4. And group 2 is the current PlayStation owners. And okay, so here we go. So it says perform a hypothesis test at the significance level 0.05 to see if there is evidence that the proportion of people who want the new PlayStation is different. Okay. So we've got a null hypothesis and an alternative hypothesis, right? This is the very first thing says what are the hypotheses, and the first one is that the two proportions are equal. All right, P1 equals P2, or also acceptable and perfectly valid is P1 minus P2 equals 0. All right, so that's the null hypothesis. All right, and the alternative is P1 does not equal P2, or the alternative is that P1 minus P2 doesn't equal 0. Okay. All right, so this is the correct answer. Now, again, the final exam is going to be multiple choice, and there's going to be what? A, B, C, D, right? And so there's going to be 3 wrong answer choices. Okay, and this is what some of the wrong answer choices might look like. Okay. So these are wrong things to watch out for, but this is you know, a lot of students mess this up. Okay. Wrong. Mu1 equals mu2. All right. These are about p. Okay. Also wrong. Anything that has p hat 1 equals p hat 2, or p hat 1 minus p hat 2 equals 0. Okay. Anything with p hat. So never, never, ever will you see p hat in a null hypothesis or a hypothesis period. Yeah. We have a question.
For the alternate hypothesis, could we do P1 minus
greater than 0. Because the question says, is there evidence that the proportions are different, I'm going to have to go with the not equals only, okay? Because the question says, you know, is there evidence that the proportions are different, okay? So different implies not equal to, okay? If I said, is there evidence that current PlayStation owners prefer the new PlayStation more, okay? If you see a word like more or greater or less or something like that, then you use the greater than or less than sign. Yes?
Wasn't there the word longer on the test?
There was the word longer, and that was for the one with the batteries.
So that's
Okay.
the same as more then?
So yeah, longer implies more length, right? So. Huh? Yeah. Okay. So yeah, you've got to watch out for these kind of these words implying whether your alternative is going to have a greater than or less than or something else. Okay. So also wrong, yeah, would be if the alternative at P1 minus P2 is greater than 0. That would be a wrong answer choice. Okay. What else would be wrong? Okay. If I put in some number here, right? Is that P1 equals 0.7 or something, right? These are not correct hypotheses. Okay, so know the correct answer, and if you know the correct answer, then you won't be distracted by the wrong answers. But if you're not sure about what the correct answer is, the wrong answers will look pretty tempting. Okay? Yeah, question.
What if you could you have done like group 1 with group 2? Like did you have to write T, or could you move like actual, make your variable the group instead of the proportion?
It has to be a P. It's got to be a proportion. If you wrote proportion of group 1, that's acceptable, okay? But group 1 is never going to equal group 2, okay? I mean, by definition, group 1 is different from group 2. They're two different groups, so the two groups could never be the same. But the proportions from the groups could be the same. That's what these hypotheses are saying, okay? Yes?
I have a question about the test.
Yeah.
If we ask you, can you email, like, once you grade the test, like, what concepts you got wrong? Or is that too complicated?
That's asking a little much from me, okay? I will grade these tests, and I will email you your grades, okay? That's as far as I'm gonna go. I'm not gonna say, oh, by the way, you missed question 3A, and what you did wrong was here, and the correct answer was this, okay? That would be lovely, but that would take me like too many hours to do, so I can't do that. So, yeah, question.
On the alternative hypothesis,
Yes.
if we were to miss, like, let's say we wrote P1 minus P2 bigger.
Bigger than 0, you'll lose a few points, right? So the hypothesis question was worth 10 points. So if you did bigger than or something, that's probably like a -3 or -4 points or something out of 10.
Minus 2.
Huh? -2. It's 10 points there, right? 10 points. So yeah. So huh? So there's 150 points total in the test. So we'll figure it out. Okay. I'm generally pretty generous. Okay, but wrong answers are wrong. So. There's 150 points total. Okay. I'm just going off of what Dr. Gimsari's syllabus said about the grades. So. Okay, so
That's our hypothesis. That's what.
that's the hypothesis for number 5. Okay. All right. Part B says, what is the observed difference in proportions? Okay. Observed difference in proportions is going to be P1 hat minus P2 hat. So depending on which version of the test you got, we've got different versions, different answers here. okay, so one said, there was, 420 out of 600 minus, 494 out of 650, okay? And so this is gonna be, 0.7 minus 0.76, and you get negative 0.06. Okay? The other version of the test was 350 out of 500 minus 407 out of 550, and I don't.
Negative 57.
Okay, so this is 0.7 minus 407 divided by 550, 0.74, negative 0.04. Okay. If you did 0.76 minus 0.7, that's fine, and you get the positive version. If you get a positive 0.06 and a positive 0.04, that's also fine, as long as your work matches up, right? If you do 0.7 minus 0.76 and you get positive 0.06, then you're gonna lose a point there because you should get a negative number. But if you did 0.76 minus 0.7 and you get 0.06, positive 0.06, that's fine. Yeah.
Alright, that's fine, okay. I was just making sure, so.
Yeah. So if you did 0.76 minus 0.7, that's fine. Huh? Round it down? I don't think there was any rounding involved here. Huh? I purposely picked numbers that won't have crazy decimals here, okay? Huh?
But my calculator was like 420 minus 494 minus 7, and I did 600 minus 6.
Okay, that's not correct, okay? You have to, you have to, like, the rules of fractions, right? If I said, you know, what's 1/3 minus 1/2, you would not say 1 minus 1 is 0 and 3 minus 2 is 1, okay? That's not allowed, okay? The answer is you gotta find a common denominator and work that way. So you can't just take the top numbers and the bottom numbers, so, I don't think I can give you any points on that if you did that, okay? But I mean, I'll try to work with you and see what how the rest of the problem goes, okay? Okay, so p hat, you add the total number of successes, so 420 plus 494 divided by 600 plus 650, and you get 0.7321 or 7312. And then the other one, you do 350 plus 407 divided by 500 plus 550, and then you get something else here. 0.72 0.721, that's fine. Let me just jot these things down. Okay. So that's part B. Is this okay?
Mm-hmm.
All right. And then it says, what is the test statistic? Okay, the test statistic. So the test statistic requires that you figure out basically what your observed value is minus your what's in the null hypothesis divided by the standard error. Okay. So once you get this p hat, you've got to figure out your standard error. So for that one, if your p hat was 0.7312, your standard error is going to be 0.7312 times 1 minus 0.7312 times 1 over n1, which is 1 over 600, plus 1 over 650. And I'm getting 0.0251 as my standard error. Got a thumbs up there. Okay. All right, so your test statistic is you take your observed difference in proportions which was negative 0.06. So my z-score here would be negative 0.06 minus what's in the null hypothesis. The null hypothesis says that we're expecting a difference of 0. So I can just put in a minus 0, and I divide by my standard error. And this gives me a z-score of 2.39, or negative 2.39.
Do I have to put -0 up there?
No, that's fine, okay? Okay, and then, and the p-value is then you look up negative 2.39 in the, in your z-table. And the area and the tail, negative 2.39, the area in the tail is 0.0084. So the area in the tail is equal to 0.0084. If you look up negative 2.39, you get 0.0084. Alright, so a lot of you guys were asking me, where am I supposed to round? Where am I supposed to round? Okay, so generally for the standard error and stuff like that, keep at least 4 decimals or whatever. If you can use a calculator where it doesn't round off and you can use the answer key, keep that and don't do any rounding. And then at the end, when you figure out a z-score, because the z-table only has up to 2 decimals of precision, at that time you can round off to 2 decimals. Alright? And then see, area in the tail is 0.0084. Is this my p-value? No, what do I have to do to get my p-value? I double it. So my p-value is 2 times 0.0084, and I get 0.0168. Okay, that's my p-value.
You doubled it up because it's a two-tail?
It's a two-tailed test. Why is it a two-tailed test?
Because it's equal and not.
Because I've got a not equal sign. I've got a not equal sign. Alright. Is that alright?
No, I mean, it makes sense, I just made a mistake.
Okay. Yes.
I think I did 2.38 maybe, is that?
Alright, 2.38. That's fine, alright?
I just want to.
Yeah. If you did the work, okay, you know, as long as you're using kind of like the right numbers here and you're getting 2.38 because of rounding issues, that's fine. If I see you check your work and you used the wrong numbers but somehow you ended up at 2.38, I'm going to take off points, okay? So I'm going to pay attention to your work and see where you get. And that's fine, okay? Yeah.
So I got the number 0.7312. I
Uh-huh.
got that right.
Yeah.
But my other number is wrong.
What's your other number? This?
Yes, this was my other number that was wrong, and then I still have the right number, and then I
Yeah,
still
okay.
put it into
So
the
you're gonna lose a lot of points for this part of the question, okay? But if you've got, so you're gonna lose points for this part of the question, but I'm gonna follow your logic and say, okay, well, assuming this was correct here, then you
No, I still
should.
used the same formula, put it in the same, like, the numbers that I had.
Yeah, okay, so let's say you did this part wrong and you got negative 0.3, okay?
And then
So in your answer, you put in negative 0.3 here, and everything else is correct. I won't take off points, okay? But you're just gonna lose points for the part that you screwed up. I think I'm generally pretty fair in the grading system. I can generally follow what students were thinking. And generally I can also tell when a student had no idea what he or she was doing. Okay? I mean, I've taught this class long enough, so. Okay, so this is our p-value. So what do we do with this p-value?
Compare it to your alpha.
I compare it to my alpha. Is it bigger or smaller than alpha?
Smaller.
My p-value is 0.0168. My alpha, it's not on the board, but in the test it says alpha is 0.05. So my p-value is smaller than alpha. And so what does that mean? It means we reject the null hypothesis. And so what decision do we make? We reject the null hypothesis. And what does this decision mean?
Means that we have enough evidence
We have evidence that
that there is a difference.
there is a difference in the proportion of people who want PlayStations, okay?
So,
Yes.
I accidentally looked at the T-score and it was like between .01 and .02.
Okay, so you'll lose points
So
on.
I'll point for that, but I did reject the
Yeah,
null hypothesis.
Okay, so you'll lose points on what is the p-value, right? What is the p-value? You've got to use the z-table, all right? You
Yeah.
use the t-table, so you'll lose that part of the question.
Technically, it is more than .01 and less than .02.
That's true, but you I mean, you got it. It was a happy mistake that your answer matches the correct answer, but you got to use the z-table and not for when you're doing proportions. You got to use the z-table. Okay. All right. Was there a question? Okay. And then so we say we have evidence
Thank you.
that there is a difference in proportions. Okay, proportions of people who want Xboxes.
Can you do the other one now?
Huh?
Can you do the other?
Oh, do the other side?
Yeah.
Sure.
Sorry.
The other version?
Thank you.
My pleasure, my pleasure. Okay, so I think this one turned out to be a significant difference, and then I think in the other one it was not significant, I think. But let's see.
Yeah.
Okay, so see here I get 0.721, so my standard error is going to be the square root of 0.721 times 1 minus 0.721 times 1 over 550, or 500 plus 1 over the other number, okay? So I do this. Alright. Okay, so I get, 0.0277. Alright, so my z-score is I take my observed difference, negative 0.04, divide by my standard error, and I get negative 1.44. I look that up in my z-table. So the area to the left of negative 0.144 is 0.0749. Okay?
Yeah, 1 minus.
It is 0.0741. That's the area in my tail. Alright? So is this my p-value? No, my p-value is double this. So my p-value, I take that and I double it, so my p-value is equal to 0.0741 times 2, and I get 0.1482. Alright, so now my p-value is bigger than alpha, so that means we do not reject the null hypothesis, and I say we do not have evidence that there's a difference in proportions.
So again, if you didn't get the p-value correct, you rejected the hypothesis. That's just some points off.
Yeah, so the p-value is 5 points. Okay, so if you screwed that up, you lose 5 points there. If you're
Right.
what
3 and 2 points.
what decision you make, okay, I'm going to look at, so I'm looking at consistency, right? Does the decision make sense off of the p-value that you found? Okay, if it makes sense, you get points. If it doesn't make sense, so if you screwed up the p-value and you get the totally wrong answer, and somehow your decision is the right answer, but it doesn't match your p-value, I'm not going to give you points, okay? I'm going off of your work, and your decision has to match the p-value that you got, okay? So if you're getting the wrong p-value, but your decision makes sense, you'll get points. But if you got the wrong p-value, but your decision is somehow, you know, because it's either you reject or you don't reject, and somehow you made the quote correct decision, but it makes no sense according to your p-value, I'm not going to give you points there. Yes, question?
What if we, like, in our minds, we knew, like, approximately what it would be?
Yeah. Yeah, no, you gotta, your process, okay, it's gotta work, okay? So I mean, I respect what you're doing here, right? You're going down on the train and you realize this thing is gonna crash and burn, right? You get to your p-value, you're getting like some crazy answer, and you're like, this surely cannot be right. I better jump and leap into the other thing, okay? Now you just gotta take it like a man and go down with your prediction, okay? So, or take it like a woman, or you know, take it like a strong person that's not afraid of where they're going, and just go with it, okay? So I gotta go off of whether your logic flow of work makes sense, okay? So if your answers line up to your p-value, that's fine. But even if your p-value is wrong, you just lose points for the p-value. The rest, that's fine. But if, you know, some people kind of like try to hedge their bets, and they say one thing and they say the other thing. Okay, it's just it doesn't work that way. Okay. But I guess, you know, on the final exam, I try not to have too many questions that depend on the previous one. There will be a few like that, okay? And that one's just kind of this non-mercy.
I mean, I guess it would be too much to ask. I guess it wouldn't hurt to ask. But you're not doing like some kind of practice test for the final.
Maybe I'll put up a few practice questions.
Like questions, yeah, just so we get the wordings and stuff like that.
And then I'll put up, I'll kind of put up my big picture, what is statistics all about thing, and
Confusing ones.
huh?
Put up some confusing ones.
Some confusing
Yeah, so we
ones.
can get the easy ones.
Yes,
on your
you get
test
the
and,
easy
like,
ones on the
yeah,
test. Okay.
exactly.
Well, we'll see what happens. Yeah, Sean.
Is there any way that you can send us like the videos on like all the you know the conditional like probabilities and stuff that you did? Because that's gonna be on the test. Like test 2 of Gamzuri is on there, but
Yeah.
can you send us
That's
videos of your videos covering those?
Like
that
the other
chapter?
class.
Alright, I'll look at the questions.
Can you just give us all hundreds on a final?
Just call it a day. Just call it a day.
Can we start with 150 points and then just work our way up from there?
That would make my life easier. I don't think the university would be too happy about that. You said these guys understood statistics.
We understand the probability of successes and the probability of failure.
They understood that a coin flip lands 50% I don't think they'll be too happy about that. So yeah, I have a job to do also. Okay. All right. So anyway, that's two proportion hypothesis test. You'll probably see something like that on the final exam with multiple choice. Yes. Question.
So is one of the formulas p hat plus or minus z times SE, or is it t times SE?
P hat plus or minus z times SE. That's a confidence interval for one sample proportion.
So it's like on your practice test it's for 90%. So how do you find it on the
Those are just the there's just set numbers. 90% is 1.645. 95% is 1.96. It's like page 320 in the book or something.
But is it on the T one though?
Hmm?
Those numbers are on the T one.
You know, there is a nice property. If you forgot, like if you happen to forget, oh, for 90% I'm supposed to use 1.645, you can go on the T table, and the row with infinity degrees of freedom happen to be the numbers that you use for
That's what I did.
the Z star. Well, you got lucky, okay? You didn't know what you were doing, but you said, this seems about right, okay? And that actually works, okay? And that's actually a valid method there, okay? Using infinity degrees of freedom for Z star. So, I've never seen that happen before, but good for you, okay?
We have one question.
Okay, so other things that we that you should know would be confidence intervals and hypothesis tests for two sample means. Okay. Interval for two sample means. And this, there is a challenge, okay, between identifying, do I have one sample mean or two sample means, okay? So when you read a problem, first off you gotta say, am I dealing with means or proportions, okay? You gotta be able to figure that out right off the bat. Okay, anytime you see a standard deviation in a problem, you'll be dealing with means. Anytime it's a numeric variable, you'll be dealing with means. Categorical variables, proportions, okay? If you see the word proportion in there, probably it's a proportion, okay? I'd say 99% of the time, okay? So you've got to know, am I dealing with means or proportions? And then you've got to say, do I have one sample or two, okay? And I know, you know, a student or two asked me during the test, do I have one sample or two? I can't tell you if you've got one sample or two, all right? But just say, if you can identify two n's, you've got two samples. If you can only identify one n, you've got one sample, all right? So that's how many samples?
Like this would be the one, sorry, this would be the one like about the gas mileage?
Yeah, the gas mileage, that was one sample, right? You had one sample because
It was 28.7.
yeah, he drove the car 20 times or something like that, okay? This batteries question on the test today, that was dealing with means. You were looking at how long the toy car worked or something, but you only had one sample, okay? One sample of batteries to look at. The other numbers from the generic batteries, there was no sample associated, so there's no two samples. Huh? Yeah, so confidence interval for two sample means, okay? So make sure you have two samples. Okay, and the confidence interval is going to be x1 bar minus x2 bar. This is the center of the interval. Plus or minus the critical value t star times the standard error, which is s1 squared over n1 plus s2 squared over n2. Easy, easy. Alright, this is the standard error. Okay, how do we find our critical value t star?
N minus 1.
Okay, n minus 1 degrees of freedom, and we look at the confidence level, right? Degrees of freedom is equal to n minus 1, and our confidence level, and we use our confidence level. But we've got two n's, right? I've got two samples, so that means I've got two n's. So what's n minus 1? I use the smaller n. Use the smaller n. Alright, so let's try an example here. Alright, alright, so let's say we take a random sample. Of used cars. All right, and okay, we'll say used cars from 2010. So that at least we have some range here. Okay, and we'll say the average, the mean. We have 15 domestic cars the mean price is I don't know, 2010. How much is a used car from 2010? Depends on the car, right?
10,000.
14 500, okay, with a standard deviation of $2,500. Okay. Okay, and we have 20 foreign cars. Okay, also randomly selected. Okay, and the mean price is 15,200 with standard deviation of 3,000. Okay. That's probably too big. All right. Make a 95% confidence interval.
So in this case, does it matter which one is, like, which?
Yeah, we'll say, let me call this one group 1. Just so it's clear, okay? But the only thing that's going to happen is when you'll get either the negative of the other, okay? If you call the other one group 1 and the other thing group 2, then you'll just get the negative version of the other thing, so.
And it doesn't matter if negatives and t's, right? It's not t's.
Yeah, the t's don't matter and things like that. Okay, so make a 95% confidence interval, okay? So this is easy because I just told you that we're doing 2 sample means, okay? But when you're reading a problem, you've got to be able to read this and say, oh, am I dealing with means or proportions? And you got to be able to see, oh, we're talking about the price of a car, now we're dealing with means, okay? And then you got to say, do I have 1 sample or 2? And then you see 2 samples and you say, okay, I'm dealing with 2 sample means. And once you figure that out, then you can say, this is what I'm going to use for my confidence interval. But if you get that part wrong, you're going to be using the wrong thing. Okay, so don't do that. Okay, make a 95% confidence interval. All right, so let me ask, what is the center of the confidence interval?
X bar 1 minus X bar 2.
Yeah, X bar 1 minus X bar 2. Alright, so that's going to be 14,500 minus 15,200. So I get negative 700. Okay. What's my T star?
2.145.
Yeah, so I have to figure out my degrees of freedom, which is 14, 95% confidence, 2.145 indeed. And what's the standard error? Well, I gotta do this crazy thing. Over 20 plus.
Over 50.
I'm sorry, this is over 15. And this one's over 20. Get 930. 930.95. So basically 931. Okay. So my confidence interval is minus 700 plus or minus 2.145 times 930.95. Okay, so I have minus 700 plus or minus 199. I'm just gonna round out to 7. So I get negative 1297 to to positive 2697. Alright, so that's my confidence interval. So what does this mean? Do I have evidence that there's a difference between the mean price of domestic and foreign cars from 2010? Did I mess something up? Oh, negative 2697 and positive 1297, I'm sorry. Negative 2697 to positive 1297. I'm sorry about that. Okay, and I would say, because my interval 0 is in the interval, so I do not have evidence that there is a difference in the mean price of used domestic cars and foreign cars. From 2010. Okay, I mean that's kind of verbose, but you get the idea. Hang in there, people. Alright. Yay? Yay? So I think, you know, people will probably complain that it was multiple choice. Okay? And again, if you know what you're doing, it'll be fine. Okay? But if you're a little bit shaky, some of the wrong answer choices will look tempting. So just learn the stuff and we'll be okay. And don't make silly mistakes because there's a good chance that your silly mistake will show up also as a wrong answer choice. So the other thing we have is we have two sample means. But we want to do a hypothesis test. So we'll say, you know, does advertising, you know, increase our revenue? All right, so we'll say we looked at 30 days without before the advertising campaign. And the average amount of money, average revenue for each day is, I don't know, $890, okay, with after the ad campaign. We looked at you know, 2 weeks of data. Days of data. Okay, and the average revenue is 990 with standard deviation 210. Okay, so did the advertising increase our revenue? Okay, what do you think? Well, what's the first thing we gotta do? We're gonna ask, what is our hypothesis, right? Yeah, mu1 equals mu2. Okay, or equally valid, I could write mu1 minus mu2 equals what? 0. Equals 0. Alright, and the alternative should be mu1. So if this is, if we call before the ad campaign, this is group 1. And after the ad campaign is group 2. Mu1 should be more or less than mu2? Less. Alright, the days before the ad campaign should be less than the days after the ad campaign. Or the alternative could be also written as mu1 minus mu2 is less than 0. Alright, so our test statistic, well, let's ask some more questions. Okay, what is the observed difference in ad revenue? Yeah, x bar 1 minus x bar 2. So I have 890 minus 990. So I have a difference that before the ad campaign, we were bringing in $100 less per day, or whatever. 100,000 less, I don't know. Okay. And the, what's the standard error?
It is x squared 1 over
S1 squared over N1 plus S2 squared over N2. Alright, don't forget to take the square root, you guys. As I was walking around, I saw a lot of people forgetting to take the square root at the end, okay? So 120 squared over 30 plus 210 squared over 14. $60.25. Alright. So, what is my test statistic?
1.771.
Yeah, I do negative 100 minus 0 over my standard error, 60.25. I get negative 1 point what?
Oh.
1.66. So what's my degrees of freedom?
13.
I have 13 degrees of freedom. Okay. And my test statistic is negative 1.66. So if I go to the row 13 degrees of freedom, the first number I see is 1.350. And then the next number is 1.771. And then the next number is 2.160. Alright, so I ignore my negative and I'm fitting 1.66. Where does it fit in the lineup? It fits in between this and this, right? 1.66. 0 fits in between here and here. And do I have a one-tail or two-tail test? A one-tail test, because my alternative has a less than sign, so this is a one-tail. So I use my one-tail probabilities, which are 0.10 and 0.05. So what is my p-value? Yeah, my p-value, whatever it is, I don't know exactly what it is. I do know it's more than 5% or more than 0.05 and less than 10%, less than 0.10. So, do I have evidence that the ad campaign increased our daily revenue? Yeah, so if my significance level is 0.05, so let's say alpha is 0.05, is my p-value bigger or smaller than alpha?
It's bigger.
Yeah, my p-value is bigger than alpha. Yes?
So why do you write the p-value, the answer, the greater than signs like that? Like, why wouldn't you do, it's greater than, like, 0.10 greater than p-value, and then the sign again, then 0.05? Like, I'm just confused on that part.
Oh.
Why you switch the numbers around?
There's nothing wrong. Like, if you want to write this, is that what you're talking about?
Yeah.
No, that's perfectly valid.
Okay.
It's just I don't know, the convention in math is generally you put smaller numbers to your left and larger numbers to your right. That's just the general convention. So I guess I have that kind of old school habit to do that. But if it's easier for you to do it this way, that's fine. Okay. Just be prepared, like, because it's multiple choice in the answers, right? You're probably going to see it written this way rather than this way. Okay. Not that this is any less correct. It just feels a little bit odd for me. Okay. As someone who's seen numbers and stuff, it's kind of like saying, I don't know. You know, I'm from California, Los Angeles, or something. You know, people will understand, and it's not wrong. It just feels a little weird. Okay.
So we didn't have to get a specific p-value.
When you're using the t-table, you can't get an exact p-value. That's correct. Okay. If you had a computer, it can give you an exact p-value. But with the t-table, you can't get an exact p-value. All right. And actually, even with the z-table, everything's an approximation too. So.
Is there a formula to find the exact p-value?
One that involves calculus and integrals, yes, there is, but we're not going to worry about that. Okay. We're just going to use the t-table and just say that we're going to get a range. So, okay, so the p-value is greater than alpha, so we do not reject. The null hypothesis, and we say we do not have evidence that the advertising increased our revenue. Is this feeling okay? All right, and so you know, when you, it's probably gonna look, you know, kind of similar to this in the form that there's gonna be a situation explained, and then there's gonna be like 4 or 5 sub-questions related to it. I'm gonna try to, make it a little bit less dependent on, you know, one answer depends on the previous answer. So I might just kind of say, what's the hypotheses, and then what's the test statistic? Let's say your p-value came out to be this. What does, you know, that, yeah.
Is there gonna be room to show our work, or we just put in the answer and that doesn't matter?
So there will be room to do your work, okay? But I'm just, for the, to speed the grading, I'm just gonna go off of the Scantrons. So there's no like partial credit on that, okay?
So we can write on the test.
Yeah, write on the test, okay? That's every single test. Okay, you can write on the test, yeah. Alright, are there any questions on this? Using the t-table, getting p-values from this? Okay. You guys are, most of you are the good students. A lot of students have left, and they are the ones that like, you guys need to stay here and learn.
You get extra credit.
Huh? Well, it will show on when you do excellent on next week's final exam, okay? So that's,
You're gonna get extra points for like not missing a class or participation. There are no dumb questions.
that's mostly true, yes.
You came up with that one,
Yeah. We're gonna break. We're almost done here. Okay, we got about half an hour.
Oh, we're only 1 to 9, that's cool.
9:30. I think it's on the clock. I've got.
Oh yeah, you're right. 8:54.
Yeah. Extra points for being beautiful. So, crush my spirits here. Okay. All right. Let's see. Okay. So I think we've covered most of the topics from chapters 8 and 9. Okay. I talked about type 1 error and type 2 error.
Yes, you did. You mentioned it.
I did or I did not?
You did.
You guys remember or you don't remember?
Yeah, we remember.
Okay, well, I better get rid of those questions then. Another class, yeah.
What chapter is that?
At the end of chapter 8, but that's, if we didn't cover it, I wanted to talk about that though. Huh? Type 1 error and type 2 error is, okay, so you go through the hypothesis test, right? Let's say your conclusion was to reject the null hypothesis, okay? So, you know, the null hypothesis says your proportion is 30%, right? The proportion of people who want a cat is 30%, okay? And you go through the process, you know, you take a survey, 34% in the survey wanted a cat. And so you say, okay, you go through the process and you reject the null hypothesis and you say, I have evidence that the proportion who want a cat is not 30%. But let's say, but somehow that was actually wrong, okay? That the proportion of people who wanted a cat actually was 30%, but somehow because your sample ended up being 34%, you made the wrong decision, okay? That's known as a type 1 error, okay? That's a type 1 error. Does that sound familiar? No. No.
We read it in the book.
You read it?
It wasn't something we retained.
It wasn't something you retained.
Well, no, because look at those formulas.
No,
like
7,
that
8, 9,
square,
we
one
all we did
over
was central limit and
Yeah,
confidence.
central limit theorem, confidence
Yeah.
interval, okay. Confidence intervals and hypothesis test, okay.
Yeah.
That's, yes, motion?
Basically, it's like you have your confidence interval and the right answer falls outside of it anyway. And that's a type 1 versus,
They're gonna be on that one time.
Yeah.
you have evidence showing that you you should reject the.
Alright,
Sorry.
okay, sorry, I've got, the wheels in my head are turning, and I'm like, okay, it's a pretty important concept, is it fair to talk about it right now and put it on the test or not? Okay, I'll put,
Bonus question.
I'll put it in the, in like my big picture statistics, this is what's important, and we'll keep it abstract, which I think is a little bit easier than it is, okay. So, alright, let's say you were a smoke detector, okay? What's your job? What's your number one job? Detect smoke, right? Okay, well, alright, and
Sound
what
the
do you
alarm.
do, what do you do when you detect smoke?
Sound the alarm.
You sound the alarm, okay? And then what's the other half of your job?
To be quiet.
Sitting there and being quiet.
Yeah, being quiet when there's no fire, okay? So, you got a null hypothesis and you got an alternative hypothesis, okay? The null hypothesis is there is no fire. And the alternative is there is a fire. Okay? For you, rejecting the null hypothesis, what does that mean?
That there is a fire?
Yeah, it means you believe there is a fire, so what do? You sound the alarm, okay? Reject the null hypothesis means you believe there is a fire, so you sound the alarm. Okay, and if you do not reject the null, that means what?
You
It
believe
means
there is no fire.
you believe there is no fire. You believe the null hypothesis, basically. You believe there is no fire. So you stay quiet. Okay. A type 1 error is rejecting the null hypothesis when the null hypothesis is true. Okay. So for the fire alarm, what does this mean?
You set off the alarm when there is no fire.
Yeah, the null hypothesis is true. There is no fire, but you rejected it, so you sound the alarm, okay? There's no fire, but you sounded alarm. So this is a false alarm. No fire, but you sound the alarm. A type 2 error is not rejecting the null when the null hypothesis is false. So what does this mean?
You don't sound the alarm when there is a fire.
Yeah, there is a fire. The null hypothesis is false, which means there is a fire, but you didn't reject it, so you stayed quiet, okay? So fire, but no alarm. Okay. So in this situation, what type of error is worse?
Type two.
A type 2 error is worse. A type 2 error is worse, right?
What about like if it's like with, 'cause I think I went through this in, research method psychology class.
Yeah.
If it's like a placebo, cause she was saying like if it was medication,
Mhm.
then.
So there's different situations,
Oh,
okay?
okay.
So this situation with the fire, and a type 2 error is a fire but no alarm, that's a worse mistake than alarm with no fire, right? Type 1 error is annoying, you're cooking toast and you're just like, shut up, okay? But type 2 error, is potentially tragic, okay? You have no idea that there's a fire because there's no alarm going on. So that's a type 2 error. On the other hand, let's talk about a criminal case, okay? In a criminal case,